Right. Thanks. Good morning, everybody. I'm Angus Atkinson from Plymouth Marine Laboratory, and we're going to do a double act presentation as we did last year. So I'm going to start and then hand over to Jeanette from the University of Plymouth and then carry on. So we've got quite a lot to talk about. So basically we've got three sections that are quite distinct in this talk. I'm going to start off by describing 2024 plankton observations, but very much in the context of longer term change in the plankton. Then I'm going to hand over to Jeanette, who's going to describe the gelatinous component. 2024, again in the context of the last sort of 5 or 6 years of change mainly. And then I'm going to, in the third section, take a slightly different tack, go into slightly foreign territory for me, which is much more talking about the links up to fish and into sort of fisheries management. So that's hopefully going to link with a few of the talks that we're going to hear later on today, for example, on higher predators, fish and fisheries management. So getting straight in, the 2024, I'd say it's part of very substantial reorganisation of the food web in the West Country. And I've described this as a decline in the classic summer food chain. And by that I mean the nitrate is fueling blooms of diatoms and dinoflagellates, in turn fed upon by large copepods such as Calanus helgolandicus that I've illustrated here, which in turn are fed on by pelagic fish. But we're seeing, particularly in the summer, a decline in these components of the classic food web, at least up to the fish, up to the copepods which feed the fish. So, for example, summer 2024 was the lowest we've ever recorded for Calanus helgolandicus, this large copepod which is a staple food for some of the pelagic fish. So not everything has declined. We are seeing more stability or even increases in other components of the food web. So, for example, the picoplankton, the small, less than 3 micron organisms, they tend to be a lot more stable or even increasing. And some of the other zooplankton taxa, particularly the large salps, which are feeding on these picoplankton, they have maintained a high numbers, and they've just increased in the last couple of years. Jeanette is going to talk a little bit more on the salp story, but the obvious question that this raises is what is causing these changes. And we just wanted to see whether it was a coincidence or not that the salps are feeding on these tiny picoplankton, and both have been tending to increase. So we wanted to look at the sort of feeding behaviour of the taxa to see if that gave us some clues onto the changes that we're seeing. So what we've done, we got the sort of 30-ish dominant zooplankton at the L4 site, and we've ranked them and sort of classified them according to their feeding mode. So the fine mesh filter feeders are the dark blue, carnivores or detritivores below that, and the light blue are the suspension feeders, for example the calanoid copepods, the Calanus helgolandicus, which tend to target the blooms of diatoms and dinoflagellates. So we did a ranking of these according to whether they've increased or decreased over the last 3.5 decades at L4. So what we see is a general pattern of the fine mesh filter feeders, for example the salps, but also appendicularians and some of the meroplankton, which use fine ciliary bands to filter out the tiny plankton. They tend to be doing best at the L4 site, and the species that are decreasing tend to be these light blue ones, the copepods, the Calanus. So there's some sort of pattern that we're seeing, but it's obviously very imperfect, and we're looking at this in a little bit more detail with the help of eDNA. That's an 11-year time series. It's not so long as the sort of traditional microscopic identification, but it gives you a lot more clues on the actual diversity, particularly for the meroplankton, which are dominating some of these increases in the plankton. So that's a sort of work still in progress, but I'll now hand over to Jeanette, who's just going to describe some of the zooplankton, the gelatinous group. So
Yeah,
I'll just stand aside.
That's okay. I'll go through these really quickly. They will be in the report if you want to look at them closer. So what we're looking at are gelatinous fauna that really can be seen by the naked eye. These are the true jellyfish, and you'll see that generally there's similar patterns for most of them. And it's the mauve jellyfish that is the standout from last year. It's not really usual to be reported around the coast of the southwest, and it was there in huge numbers. The colours represent the largest number of individuals seen in a single sighting, but they so anything over 50 would be coloured black. But actually there were thousands and thousands of them this year, and they stretched at one point, they stretched all around the coast of the southwest and beyond, and there was a swim from Land's End to the Scilly Isles that had to be cancelled because so many people were being stung even though they were wearing wetsuits. I'm just going to do a little bit of the history of the mauve stingers. So the scale, the vertical scale is not to scale, it's just the big bars are where there were really big swarms of over 1,000, and then we have medium-sized bars where there were maybe one or two sightings of about 100, and individual sightings. The red is Irish and UK waters, and the blue was specific to southwest of England. So 2007 there was a really big swarm off the coast of Ireland. One estimate was 500,000 individuals on one beach stranded. There's mass mortality at various fish farms. So they started a survey which started in 2008. And you can see that survey showed that these animals were present in UK and Irish waters. But the next big bloom that we've had has been in 2024, all around Ireland and the UK. This is the Irish survey. So the dots are their sampling stations, and purple dots show that they actually had the mauve stinger found. The size reflects how many. So pretty much these animals have been around the Irish waters most of that time, not always in the same place. You can find this on their own Facebook page for the big jellyfish hunt. And then just to give you a bit of further history, if you look at the bottom of this slide, we've got sightings across the decades from 1840s up to 1900s. Obviously, these are not going to be as complete as we have now with citizen science and surveys. These were very much science stations reporting. So you can see that there were these huge numbers in the 1890s and in 1966, and you get descriptions like it's like a carpet of red. But I'll move on to some of the others. So the comb jellies, ctenophores, we do get some reports as sea gooseberry or burrowy, but mostly people just tell us they're comb jellies. So really it's the one on the right that's showing you that they're around most of the time, but they weren't really seen so much in 2019, or at least not reported. If we go on to the hydrozoa, so the crystal jellyfish was a big story last year. The numbers, again, the fact that they're showing across all years doesn't really indicate just how many there have been in the last 2 years. They've been everywhere. The Portuguese man of war was not reported as much in 2024, but the by-the-wind sailor, which we had been expecting in the autumn and winter, seems to have been washing up much more in the spring and summer months. And then the salps. So you can see that there were no sightings really in 2019 and very few until 2023. So the really nice picture on the right-hand side shows someone snorkeling through this field of salps in 2023, and we've got lots more evidence of exactly the same thing from last year. But interestingly, there do now appear to be 3 different species, but I can't tell you what they are.
Thank you. So we've just heard that there's been some quite big changes in the plankton in the West Country. So this third part of the talk, I'm going to go much sort of bigger picture and look to see what these changes in the plankton mean, both spatially, further afield, and up through the food web to the predators of the base levels of the food chain, for example, fish and some of the higher predators. So to introduce that, I just want to provide this sort of simple idea of trophic pyramids where the phytoplankton and zooplankton that we've just been talking about, they're feeding the higher trophic levels. I've just illustrated this with fish, but of course you can go up through to the cetaceans and marine birds and what have you. But just to illustrate with fish, so we've got this trophic pyramid of biomass. So if you decrease the phytoplankton at the base of the pyramid, you naturally tend to get a lower supportable biomass of fish, all things being equal. But you can also reduce the efficiency of the energy flow through the food web. So with a less efficient flow from one trophic level to the other, you're flattening the pyramid and you also get less food available to the fish. But if you do both at the same time, you get an amplified effect. You're squeezing the base and you flatten it, so you're getting a much reduced level of fish. And that's what we actually wanted to look at to see if this is happening. When you decline the phytoplankton, which is tending to be what we're getting, because the climate change, it's tending to warm the ocean, cut off the nutrient supply, that's reducing the flow of nutrients to phytoplankton, lower phytoplankton biomass. Is that affecting the efficiency of the food web? So what we wanted to do is plot, for a lot of ecosystems, plot the width of the pyramid base, which is the amount of phytoplankton in the ecosystem, and to see how that reflected the size structure of the pyramid, which is the steepness on the y-axis. So we got 41 ecosystems with really, really good size structure in the pelagic. And what we tended to find was that there was some sort of systematic relationship between the width of the base and the height. So the systems up in the top right are relatively efficient energy flow to fish, high phytoplankton. Bottom left, much less efficiency, flatter pyramids, and they're basically oligotrophic, very inefficient systems. So all things being equal, the ones on the bottom left are very inefficient in supporting fish biomass. So that's actually a really good property because we can get a first order prediction from the amount of phytoplankton, what is the supportable biomass of these higher trophic levels. So the traditional way of doing this is in relation to climate change and projections is these relatively complicated food web models which have a lot of very, very poorly constrained processes. But with this size spectrum, we can actually go from a much more direct and semi-empirical approach because these ecosystems in the meta-analysis, they're already adjusting and adapting to the multiple stresses of climate change. So they're basically the size structure is an emergent property from the climate change. So we're going from this food web to the empirical approach. So this is the projection for the middle of the century under a reduced emissions scenario for the change in the supportable biomass of fish. So there's a modest decline in phytoplankton, which is amplifying into a much more serious decline of fish, even by the middle years of this century. So obviously that's a projection. It's impossible to verify a projection, but one clue that we've got that we are actually on the right track, we've got past change. We've heard from Tim that there's been like 50 years of warming of the Northeast Atlantic. And that has actually reduced the biomass of the trophic level immediately below fish. So this is a decline in zooplankton biomass over the last 60 years. So that's giving a little bit of confidence that with another sort of 30, 40 years of warming, we're going to get a continued decline in the supportable biomass of fish in the waters around the UK. So we wanted to go one step further than these sort of projections of fish carrying capacity, and this is work that Matt Faith has been doing for his PhD. I don't know if Matt's in the audience, but if there's any specific questions, please dig out Matt if he's around, and he can provide a few of the detail on the answers. But basically, it's a tripartite risk approach adopted by the IPCC, combining hazard, exposure and vulnerability. So I'll just talk you through these. First of all, hazard. This is what we've seen. This is the decline in the carrying capacity of fish that we're projecting from the plankton size structure. So that's the projected fish decline. But that needs to be combined by the current intensity of present-day fishing activity. So that's basically pelagic fishing activity. So some of the hot spots of present-day fishing activity, for example, west of Spain, are coinciding with the biggest projected declines in the carrying capacity of fish. But the third factor is the economic dependence on fish. So some of these hotspots are very, very strong in supporting the national economies of the fishing nations. So, for example, you've got a hotspot around Iceland and a cold spot around the UK, which is less dependent on fishery. So we wanted to multiply all of these factors together, which are scaled from 0 to 1, to get an integrated risk assessment of the fishery, of the changes in the fish. So that's what we've done. So we've got hotspots of high climate risk of fish extraction. So, for example, north of Scotland and southwest of Spain. And if you look at the UK, southwest UK, I'd say on the big scale of things, it's sort of medium to high risk. And compare that with sort of some of the island nations of Southeast Asia. Big climate change impacts on the fish, on the fishery, very high fishing intensity, and they're totally dependent on the fishery. So that's just sort of trying to get a little bit more of a holistic scale on the links between the plankton and the fish, and in turn the socio-economic dependence. So that's obviously sort of what we wanted to do, is get a semi-quantitative and integrated risk assessment that goes up from the plankton in a sort of structured way, looking at the plankton size structure, right up through the fishery into the management. And I think the buzzword is climate smart, and by that it means management and that is actually responsive to climate change, not just looking at the here and now. So I think I've got a minute or so left. So just to wind up, we heard that we've got some big changes in the food web. We've got some newly increasing taxa. Jeanette mentioned the mauve stingers and also the salps. We've got some sort of fundamental readjustment in the composition of the food web, of the plankton food web, and as well as the actually abundance of the phytoplankton. And that's got some larger scale implications for fisheries and in turn for fisheries management. So that's it. Thank you.
Thank you very much.